This video presents FILO. FILO is a tool for detecting FIx-LOcus candidates in Android applications with issues caused by the upgrade of the Android framework. Here, we can see two emulated Android devices and their consoles, running two consecutive versions of the framework, namely API 22 and API 23. On each device, we install the same application and we are running the same test case. The test case passes on the device running API 22, but fails on the device running API 23, therefore highlighting the upgrade-related issue. In this example, when the top right button is pressed to request a forecast for the current location, the app on the API 22 successfully produced the output, while on the API 23, the Find Current Location message window hangs indefinitely, blocking the app interface. We exploit Appium to build our test cases, but different already existing test cases can be used instead, as long as they highlight the upgrade-related issue. To collect the execution traces, we exploit a custom-made expose module. The module is able to start and stop the native Android tracer that records the app execution. The native Android tracer is very light. However, it is unable to gather detailed information, such as complete stack traces and return values, which are needed by FILO. When the test execution is finished, we can use the Android Debug Bridge tool to pull the trace file from the device. This is an example of a trace produced by the Android tracer. The second step consists in identifying the boundary methods from the traces we just collected. For this, we need the trace itself, as well as the dmTraceDump tool, usually provided with the Android SDK. At this stage, the size of each uncompressed trace can reach up to more than 1 GB. The longest part of this step is the execution of the dmTraceDump tool to extract the compressed trace file. The output of this computation is a JSON file containing all the boundary methods invoked during the execution of the test case. This is an example of a JSON file containing all the boundary methods invoked in the test case. The third step consists in executing again the test case. This time, we exploit a different expose module with a custom logger. The logger exploits the JSON file previously created to collect execution traces with more detailed information about the boundary calls with respect to the traces produced by the native Android tracer. As before, the test case passes when executed on the API 22, but fails when executed on the API 23. When the test execution is finished, we pull the new trace from the device. This is an example of a trace created by the custom logger. The fourth step consists in generating the ranking. This is achieved by executing the trace analyzer. The main inputs needed by the trace analyzer are the baseline and failure trace files from the previous step. The tool will automatically perform all the phases of FILO: anomaly detection, failure call tree generation, and ranking generation. The anomaly detection phase compares the traces to produce the suspicious invocations blocks. It also assigns to each block a representative and a weight based on its size. The failure call tree generation phase exploits the representatives to create the failure call tree, as well as the weights of the blocks to assign a suspiciousness score to each node. In this example, a darker color represents a higher suspiciousness of the node. The ranking phase analyzes the failure call tree, combines the duplicated nodes, discards the framework methods, and presents the resulting ranking to the developer, ordered by the suspiciousness score. The developer can use the ranking and the supporting evidence in the blocks to identify the portion of the code that should be modified to fix the issue. In this example, the top of the ranking points out the two methods that should be modified to produce the fix. The issue to be fixed is a wrong permission handling while requesting a location update, which is what the supporting evidence suggests with the two methods check self permissions and request location updates.